In this video, we're going to cover learning objectives A and B. B is the first one. We're going to identify if an equation is a polynomial function and then write them in standard format. So what a polynomial is, an example might be y equals 7x cubed minus 5x squared plus x plus 3. This is considered a polynomial, and how you tell is you look where what the exponent is, and we can only have exponents that are positive whole numbers. By the way, x to the first here, that's a 1. And that 3 is fine. So we have the highest exponent is a 3, the other's a 2 and a 1, and that's great. So that's considered a polynomial. What would not be a polynomial would be something that looks like y equals x to the negative 2 power. That's a problem because this is not a positive exponent. It's a whole number, but not a positive. Another one that might be an issue, y equals x to the 1/2 power. That's not a whole number, but it's positive, but it's not considered to be a polynomial. Another example that's not a polynomial would be like y equals 1 over x. Yes, 1 over x, or y equals 1 over x squared looks like it might be a polynomial, but this x value must be on the top of the equation, as we see over here. Now, standard format just means that the polynomial must be written with the highest exponent first, followed by the lowest exponents. So for example, what if I gave us this equation first? Y equals negative x plus 3x squared plus 7x cubed minus 1. And they wanted it in standard format. So what I would look is the highest exponent is x cubed, so that comes first. The next highest is x squared, that comes second. This first one here is actually x to the first, so that would come third. And then we would follow up with this number, which we call the constant. So this would look like, in standard format, would be y equals 7x cubed plus 3x squared minus x minus 1. While we are on this slide, let's also look at learning objective C. Identify the degree and leading coefficient of a polynomial. First, the definition. The leading coefficient is going to be the constant value in front of the term with the highest exponent. So if we look at this polynomial written here in the blue, the leading coefficient is the constant value in front of the term with the highest exponent. So in this case, our leading coefficient would end up being the number 7, is what we would say. Next definition is the degree of a polynomial. The degree is the highest exponent. So again, looking back at this particular polynomial, the degree of this polynomial is going to be the highest exponent we see, or the 3. So we would say it is a third degree polynomial. The last vocab word is constant. The constant value is the term that is just a number. Again, looking back here, there's only one term that's a single number by itself. It's this right here. It's negative 1. So we would say that the constant value in this is negative 1, and we would write negative 1. Let's start applying that vocab. Let's look at this first line because there's 5 different polynomials I want to talk about. This first polynomial here is one where you don't see any x values at all. There really is an x value here. This says f of x equals 8, or y equals 8, for example, or g of x or y is equal to negative 3. The x value you don't see is x to the 0 power, because remember in section 6.1, anything to the 0 power is 1. So therefore, if we look at the degree, x to the 0 power, 0 is the highest exponent, the degree of this function is 0. Anything to the degree of 0 we call the constant value. Now the second example is right here. General format is ax plus b. Here's a nice numerical example, 2x plus 7. This does meet the polynomial requirements, and it is in standard format. If I asked you what it's called, or what degree it is, this is x to the first power right here. The highest exponent is 1, so that's the degree. What we call that is linear. Now if I were to ask you what is the leading coefficient, it's the number 2. The constant here is 7. The third example is ax squared plus bx plus c. Here's the numerical numbers with 4x squared plus x minus 5 which is in standard format and is a polynomial. The highest exponent here is a 2, therefore it's a second degree. Second degrees are called quadratics. Now on here, the leading coefficient is the number in front of the x squared, which is 4. The constant value here is actually going to be -5. Our fourth example here, we're going to jump right to the numerical example. Careful, the highest exponent here is a 3, therefore it's third degree. Third degree is called cubic. This is a polynomial and it's in standard format. The leading coefficient here is a +2. The constant value is the number by itself, or -1. The last one we're going to look at here, the highest exponent in this numerical example is a 4, so it's a fourth degree polynomial. Fourth degrees are called quartic, kind of like there's 4 quarters and a dollar. In this example here, being in standard format already, if we go to the highest term in standard format, the coefficient we see in front of that is a 3, so that is our leading coefficient. The constant value is the number all by itself. It's a +4. So this slide is a great example of stating the degree in terms of the number, the word for that degree, our leading coefficients, and our constant values. As we look at this one, we want to determine if it's a polynomial. The highest exponent we see a 2, we don't see one there, we see a 3. So the exponents are whole numbers and they're positive, so yes, this is a polynomial. And to put that in standard format, I would do f of x. The highest term first, so on this one it's x cubed, so it's 7x cubed. Then x squared is next, so it's plus 2x squared. And then -1 is the standard format for that. Now if you were asked to state what is the leading coefficient, the degree, and the name of this polynomial, we can do that. Being that this is already in standard format, we're going to notice that the degree on here is 3. Any third degree polynomials are called cubics. If we go to that first term when it's in standard format, the coefficient in front of that term we see is a 7. So our leading coefficient in this case, I'm just going to abbreviate, is the number 7. If we were asked what is the constant value, the constant value on this, be careful, is a -1. So if we take a look at this one here, we're going to identify if it's a polynomial. If it is, we'll put it in standard format. So for this particular equation here, we can tell that the answer here would be no. The problem is this guy right here, that x to the -2 power is not a polynomial. So when you're asked these questions on Schoology and then it asks you for the degree, the standard format, and leading coefficients, all you're going to want to type then is put the word none, because it does not meet the polynomial requirement to begin with. If we look at equation C here, is this a polynomial? Now be careful, this is tricky. We're just looking at the x values. So here's x to the first, here's x squared. Those meet the properties where the x's are on the top level. The exponents are positive whole numbers, so that's good. So is this a polynomial? Yes, it is. Let's put it in standard format. So x squared is first, and be careful it owns a sign in front of it. So I'd write f of x equals -4x squared. And then it's that pi times x, and it's a plus, so I'm going to put plus pi x. And then I follow up with plus the square root of 5. Now, if we were asked again, what is the degree of this particular polynomial? In standard format, the highest exponent we see is a 2, so the degree here is 2. Second degrees, the word we call them, are called quadratics. Let's talk about the leading coefficient. So I'll just put leading coefficient here to abbreviate. We go to the first term, and the coefficient in front of that we see is a -4. So the leading coefficient is a -4. The last thing, if we were asked what is the constant value on here, the constant value that we see is the number by itself. It's a positive square root of 5. This example here wants to know if it's a polynomial. Starting off, it looks really good. We have x cubed, we have x squared, and we have x to the first. However, this guy right here, the exponent must be a number. Here the exponent is a variable, so no, this is not considered a polynomial. As stated before, then on Schoology, what you're going to need to type when they ask you for the leading coefficient, degree, and other components is the word none.